So results from our analysis shows that these are the final 11 according to the parameters that we used in our analysis. Hello everyone, welcome to Intellipaat's YouTube channel. In this session, we are going to do a data analysis on the IPL auction data. So with all the buzz around the IPL auction, we have decided to put Python at task and see if we can derive any useful insights from the IPL auction data. So let's take a look at the agenda for this session. First of all, I'm going to give you a brief introduction to the IPL auction data, and then we will move on to the data analysis, where we'll discuss data analysis in brief. After that, we'll discuss the steps involved in data analysis and how we are going to analyze the IPL data to find the best 11 among the players who have been sold this year. And finally, we are going to sum up with the results of our data analysis. I hope the agenda is clear to you guys. So without any further ado, let's begin. Before we begin, don't forget to subscribe and press the bell icon to get latest updates from Intellipaat. Introduction to IPL auction data. So the IPL auction data consists of various players that have been sold in the IPL auction 2022. The dataset contains all the batters or the batsmen that have been sold in the IPL auction. It contains all the bowlers that have been sold in the IPL auction. Amongst those are the all-rounders and the wicket-keepers as well. Because these are the categories in which the players are being sold in the auction. And after that, we also have the uncapped players who has not yet played any IPL matches. So we are going to filter those out later on in the session so that our analysis is foolproof to the point where we don't have to consider those players for now. Alright, so this is the information about the IPL auction data. And with all these players, we have parameters like nationality. There's a parameter of runs they have scored in all these matches. And amongst those are the average and the strike rate for the batsmen, and there are parameters like bowling average and bowling strike rate for the bowlers, and then again we have parameters like catches, stumps and runouts made for the keepers as well. So this is a brief introduction to what the IPL auction data contains, and we'll quickly go through the summary of whatever we're going to discuss in the session, and then we'll move on to the hands-on part. Before we begin, let's quickly introduce data analysis. So whoever is not aware of what exactly is data analysis can get on the session as well. Data analysis is where you gather, clean, transform and reduce useful information from any unstructured set of data. So we can define data analysis as, let's say for example, we have unstructured data. We will gather that data. We will then put it to some use. Through computations, we will clean that data of the noise and reduce redundant values, and then we will transform the data into something that can be used in a programming language, or we can use, let's say for example, Python to analyze that data, and after that we'll deduce the useful information or insights from that data through visual representations. We can use machine learning models and other things that are being covered in the data analysis part. So now that we have a basic idea of what exactly is data analysis, let's move on to the next part, which is how many steps are involved in analyzing the data. For example, let's say we have this IPL auction data. How are we going to analyze this? First of all, we have to gather the unstructured data. After that, we move on to transforming the data into something that we can load onto a program. For example, if we are using pandas, we'll have to make sure that if we are loading the data into our program, it has to be in a compatible format so that we can actually make use of that data. After that, we are going to clean the data of all the redundancies, which can be null values, which can be irrelevant values that are not needed for our analysis, and all those things that we have to clear in the step 3, which is cleaning the data. After that, we analyze the data. For analysis, we can just use basic computations, and for that we'll figure out how many parameters are useful for us and how we are going to derive any useful insights from that. And visual representations also help a lot in analyzing the data. Once we have cleaned the data, transformed it, and have loaded the data on our program, we can gather visual representations using Matplotlib and Seaborn library in Python, and we'll get a clear idea of how our data looks like and is there any relationship between the parameters that we have inside the data. So these are the basic steps we can use to derive any useful insights from any structured or unstructured data. So after this, let's also take a look at how we have analyzed the IPL auction data in our session that we'll begin in just a short while. First of all, we have gathered the IPL auction data from various sources, and we have consolidated all the information in a CSV file where we have the player names, the nationality, and what kind of a player that particular person is. Is he a batter, bowler, keeper, or an all-rounder? Then we have also mentioned values like capped or uncapped. Have they played an IPL match before or not? Those values. And after we have gathered all these data points, we have cleaned the data and removed the noise. For example, since we are not going to be analyzing the uncapped play because there is not enough information on those players about the statistics related to the game, we have decided to remove them from the data for now. And that is basically how we have reduced the noise from the data. And any null values or redundant values, we have also reduced them to either zero or we have completely removed them from the data set. After that, we analyze the data for useful insights in which we basically gather is there any relation between the parameters that we have used. For example, if we want to see how many players have average more than, let's say, for example, 130, we'll have separate computations for that, and that's how we are going to analyze the data. Similarly, when we have analyzed the data through these computations, we'll put visual representations to good use and we'll visualize the entire analysis so that we'll be able to make our decisions more efficiently. And finally, when we have gathered all the insights and we have looked at all the visual representations of all these parameters, we'll come up with the best 11 according to the analysis. So that's how this session is going to go, and let's move on to the hands-on part where I'll explain you how the code works for the IPL analysis. So this is a simple notebook we have curated for this problem statement in which we have consolidated the data that, like I have told you, for all the sold players in the IPL 22. And in this data set, we do not have the unsold players, and we also have accumulated all the retained players from all the franchisees and put them with these players again. And then again, the data contains information like matches played, runs, wickets, average, strike rate, bowling strike rate, economy. Then there is a number of wickets they have taken, catches, run out, stumps, etc. That we're going to take a look at those data points just in a short while. And our end goal is based on these data points, whatever we have mentioned until now, we will try to create the best 11 from these set of players from the current campaign. And basically, I'm just going to summarize whatever we're going to do in the session in these 5 points. First of all, we are going to extract and load the data. Extraction, we have already done, consolidated the data set. And after this, we have to clean the data and remove all the noise, which is the redundant values and all the data points that we do not need for our data set. And then again, we are going to analyze the data on different parameters, visualize the important statistical findings that we are going to get from the data. And after that, we are going to make the best team of 11. Now, this is the fun part. What we have done is we have consolidated the information from the winning team from the ICC T20 World Cup, which was Australia, and how the squad formation was there for them. And then again, for the last IPL campaign, whoever has won the formation, the squad formation that they had used in the final match, we have considered those, and according to those, we will put our best 11 in the exact same squad formation. So now we can begin. First of all, we will import all the necessary libraries which we are going to need for this particular data analysis. First is NumPy. Then we have to import pandas, Matplotlib, and Seaborn. So NumPy is going to help us with any computations related to numbers, and then again, pandas is going to help us load the data and display with data frames and everything else. Matplotlib and Seaborn is primarily going to be used for data visualization. So after we have imported all these libraries, we'll move on to the part where we load the data. So to import the dataset, we have used the package from the Python programming language, which is I have just told you about these packages that we have loaded, and PD, which is an acronym for the pandas library that we have imported over here. We are using the read CSV method to import the IPL dataset that we have curated or we have extracted from various sources. Now to look at the data, or the first look, here it is, guys. I'm just using the head method, which is going to return the first 5 rows of our data set over here. Now this is the first look at our data set. So you can see we have all these players, then there is a team which they belong to in the current campaign. There is a nationality we have used because we want to make sure that only 4 overseas players are going to be in our best 11, and that's how the analysis should be. Before we were going down this path, because we want to make sure that at the end of the analysis only 4 players should be in the best 11. Then player type, basically just to segregate the number of batsmen, number of bowlers, and number of wicket keepers and all-rounders we are going to keep in our analysis. So these are going to be 4 different analyses based on the player type. After this, we have the capped information, which means they have already played an IPL campaign. And if it is 0 or if it's 2 for some, for example, in the entire data set, there are 3 values we have used for capped. One is for players who have already played IPL campaigns, and 0 is for those who do not have any prior experience of playing an IPL campaign. So we'll filter those out later on in the session. After this, we have the information like matches played, the runs they have made so far in their campaigns, how much they are averaging, the strike rate, number of wickets if they have, and the bowling average, the economy, everything, bowling strike rate, catches, runouts, and stumps. So these are the values, and as you can see here, you can notice the NAN values, which is basically the noise in our data set, and this is what we have to figure out later on so that there is no noise in our data also. Moving further, this is the describe method, which basically gives you the information regarding the count, the mean value, the standard deviation, minimum, all these values. This you can check just to get a vague idea about what the entire dataset looks like. And we have already checked the number of null values using the is_na method. So if you use this is_na method, it will tell you if you have any null values in the dataset. And then again, we are using the sum method over here, which returns the number of NaN or NA values in the dataset. As you can see in the matches played, we have a lot of NaN values, and then for runs also we have, for average we have, strike rate, and all these values. For catches, runouts, and stumps, we have more than 208 values, because we have only consolidated the information regarding these 3 parameters for wicket keepers. For bowling strike rate and bowling average, economy, wickets is entirely for the analysis of the bowlers, and including these and the batting average, strike rate, runs, and matches played is going to be used for all-rounders and batters. So now that we have a vague idea about how our data set looks like, how many null values are there, and what is the mean and standard deviation of all these values we have in the data set, we can also get the data type of each of the elements or each of the columns. So for player name and all, we are getting object here. Then for the rest of the values, the data type is float, and it's actually returning us with all the non-null values. So for player name, there is no null values because we have 235 rows in the 16 columns, and we have 235 non-null values. So we have the entire information regarding the player name, which we got from the IPL auction from various sources. Now for team also, we have the exact data, the nationality, the player type, we have the exact data. If they are capped or not, we have also. For matches played, we don't have a few values. There are 20 null values here. Then for runs also, there is some inconsistency because we have not mentioned that for bowlers. And then again, for strike rate, we have some redundancies for wickets and all those things. So since we have a clear idea about the data, we have loaded it into our program. The extraction loading has been done. Now comes the part where we'll transform our data, basically clean the data from all these redundancies and narrow our analysis to a point where we don't have to worry about these things. So in the above data, as you can see, players have been segregated on the following parameters. First is capped. There are batters, bowlers, all-rounders, and wicket-keeper. So we are going to focus on these players only. The uncapped players, since these players do not have a lot of statistical data available from the internet, or let's say wherever we have gathered the information from, we have decided to keep these out of the loop so that we can only focus on capped players for now. So the uncapped players basically are playing IPL for the first time. So these players, if you do your further analysis, can be the surprise package for any franchisee. And since we have only limited our parameters to just the basic statistical figures, our analysis is not foolproof because there has to be number of parameters that we can include. For example, let's say batters. We have to consider how many runs they're making in the power play, how many runs they are making in, let's say, for example, the death overs, and how many times they have been, caught out, or how many times they have been out on for example, a full length delivery, or how they are playing the short length deliveries. These are the other parameters that people also can consolidate and consider for their analysis. But we have stuck to only the basic parameters so that it's easier to explain to everyone, even though they are a beginner or not. So let's begin where we clean our data set So cleaning the data set basically is getting the only values that are going to be required for our analysis. So here we are just segregating the capped batters, which means the batsmen that have already played an IPL campaign. So how are we going to do that? So we are going to locate only those rows and put the entire data frame in a data frame called batters, where the player type is a batter. So this will limit our search from the data frame and create an entire data frame for just the batters. After this, what we have to do is filter out the capped and uncapped players as well. So for all the batters that we have consolidated in batters, we have created another data frame called batters new, in which we have located all the rows where capped is equal to 1. So this will create a new data frame which will contain only the information about batsmen who are capped. And after that, we have created a final capped batters dataset in which we only have the columns that are going to be required for our analysis, which is player name, team nationality, matches played, runs, average, and strike rate. Because to analyze how a batsman will play, we only need these parameters initially. I mean, we can further narrow down our analysis by adding more parameters, but that's for later. We're just going to stick to these parameters for now. Now, when I get the information about the capped batters, this is how the dataset looks like. We have all these batters, their team nationality, matches played, runs average, and strike rate. Similarly, we have done that for bowlers also. Then again, bowlers, we have changed the bowler type or the player type to bowler, and we have located all the capped players. For the parameters, we have taken player name, team nationality, which has been in the batters data also. And then we have stuck to matches played, wickets, then there is bowling average, economy, and bowling strike rate. So these are the parameters that we want our bowlers to focus on for our analysis. Now then again, the final capped bowlers dataset looks like this. So this is how we have consolidated the information for the bowlers. And then after this, we have the capped keepers. Now for keepers, we are using only the data which will showcase their batting performances and how they have kept the ball behind the wickets, which is basically how many catches, runouts, and stumps they have made. So this is how we have consolidated the information about the keepers by using the keeper as the player type over here. Then the capped is equal to 1 because we only want the capped players and all these parameters. So this is how our data looks like. So we have all these keepers that were sold in the IPL auction. We have all these matches played that they have, the runs, average, strike rate, catches, runouts, and stumps. Similarly, we are doing this for the capped all-rounders also. Basically, what we have done is the type or the player type is the all-rounder over here. We have done the capped is equal to 1, and we have got all the capped all-rounders, in which now this is a fun part. We have kept the batting and the bowling performances for the all-rounders because in the game they're going to be used for both of these options. So we have kept all the batting parameters and the bowling parameters as well. And this is the first look at our all-rounders data. So we have all these all-rounders, and this basically this entire data set for all the capped all-rounders is longest because these have the most number of elements or the most number of columns where we'll do our analysis. Now, since we have segregated the data, we have done only the first part of the entire cleaning the data part over here. After this, we move on to filling all the null values with 0, because we don't want to keep it as a NaN value because it may cause redundancies in our data. So we just kept it to 0 so that it doesn't make any difference at all. So we have done that for capped batters, for capped bowlers, all-rounders, and keepers also. Here you have used the fill NA method, which basically fills all the NA values to whatever we have provided over here in the argument, which is 0 for our case. Now, to check if you have made the corrections completely, without any mistakes, you can check if there is any null values in your final batters, bowlers, and all-rounder data. So we have used the is NA method that we have done previously also. So here you can see there are no null values, or even if there were, they have been replaced with 0. After this, we come back to our initial analysis. So now that we have all these data sets which have only the batters, bowlers, all-rounders, and keepers data, now what we'll do is start with the analysis of batters data or batsman data. So here what we'll do is we narrow down our analysis to the batters only who are averaging more than 32. Since let's say for example from out of the 235 columns, let's say there are 100 batsmen, and for our team what we are going to aim for, we only need let's say 3 or 4 batsmen. So we don't want to analyze all the batsmen. So to just narrow it down to only a specific group, we have used the average of each of those players, and whoever has more than 32, the average, we are using then again the LOC or the log method over here, which is going to segregate the data further to only those players who have average more than 32. And now we sort the data based on each of the parameter, right? So for that we are going to use the sort values method, and this is basically going to sort the entire players who have average more than 32 into ascending or descending orders. So this can help in our initial analysis before we visually represent all these values. So we have done this for averages, we have done this for strike rate, we have done this for runs and for matches played. So let's take a look at how each of these data frames looks like. So first of all, we have the top batters average. In the top batters average, you can see we are going down in the descending order. So the most average anybody in the campaign who have been sold has 47.43, and the last one who has more than 32 average is 32.90. So we have narrowed it down to how many? I think 8 players over here which we need for our analysis, and out of these 8 players we'll choose let's say 3 or 4 batsmen that will be in our best 11. So we know for sure that out of these 8 players, the top 3 are KL Rahul, Ruturaj Gaikwad and David Warner, who have the top 3 averages among these lot. Then again we do this for strike rate, and we have all these values for strike rate, where the highest is 139.97 and the lowest is 126.60. Now based on this, we can figure out some similarities in our data, like who is going to top these charts. If we just analyze the strike rate and average, the top 2 players we have already got, which is David Warner and KL Rahul, because both of these players are in the top 3 here. So we know for sure that these 2 players are going to be there if we just consider the strike rate and the average. Now since we are using 4 parameters, we have to keep our analysis not limited to just 2. We have to do it for the other 2 parameters as well. So now we check the batsman's run again in descending order. So the most are from this gentleman Virat Kohli over here, and the least are from Ruturaj Gaikwad over here. So this also creates a little bit of imbalance in our analysis. Right now we were looking at let's say David Warner and KL Rahul. Now we want to consider Virat Kohli, Shikhar Dhawan, and David Warner again is in the top 3 over here. So this basically means that David Warner is going to be in our batsman list when we come up with the final 11, because he is already topping the 3 charts over here. And now again we look at the 4th one, which is the how many matches the batsmen have played. And here then again Virat Kohli is topping the chart. Then we have Shikhar Dhawan and David Warner. Since David Warner is in all 3 or 4 of the parameters that we have used, we're going to keep David Warner in our team first of all. After that, if you just rank down these players from 0 to let's say 10 on each of these parameters, for averages, for strike rate, for batting runs and for batting matches, you will come up with a list where you'll have 3 top players, and those are going to be David Warner, KL Rahul and Virat Kohli. Since Virat Kohli is topping the charts in 2 of these 4 parameters, and then again he was somewhere around the 7th position in the strike rate, and in the averages he was also not very behind. So that's why we have kept Virat Kohli. And KL Rahul also, again, the number of matches he's down the middle somewhere, and for the runs also. So this is how our initial analysis looks like. Then again we'll visually represent all these information and look for better insights. For now, we are keeping David Warner, KL Rahul and Virat Kohli in our batsman list that are going to be in the final 11. Now we move to the bowlers data. Now we do the same thing again. For top bowlers, we have done one thing. For bowling average, whoever has less than 24, we have kept only those players in the top bowlers list. The reason for doing this is because The more the average, it's not looking good. I mean, it doesn't look good for the bowlers. The average has to be less, which means they are basically getting more wickets. And now we have done the exact same thing, the sorting values for the bowling average, the bowling strike rate, and for wickets, economy, and matches. As you can see, I'm not mentioned the ascending parameters in these three values because we want these values to be in a ascending order. Now after this, we take a look at each of these parameters one by one. So for the top bowling average, we have all these values. Now again, there were a few redundancies when we were extracting the data. That's why we have all these values over here, because they've only played 1, 2, 1 matches, and this gentleman has also played just 3 matches, and that's why they are showing on top of the chart over here. So we'll consider players from, let's say, here. So all these values are for bowling average. So the most efficient is the guy Joseph, who's in the Gujarat team. And after that, the least is Varun Chakravarti from the Kolkata side. So these are the top bowlers for the bowling average. Then again, we do the analysis for top bowlers strike rate, and we have done this for ascending order as well. So you can see we have Joseph and Varun Chakravarti at the end. We have players like Angidi, there is Kagiso Rabada and Arshdeep Singh, and all these players who have the strike rate over here mentioned. Now we have done this same thing for the economy as well. Now this is where the chart actually changes. So for the least is Chakravarti over here. The gentleman has only played 31 matches. And then we have Jasprit Bumrah. Then we have Nathan Kuntal. There is Yuzvendra Chahal. And at the end we have Alzari Joseph. Because we're not considering Rasik Dar and Sean Abbott. There's one more player we are not considering, which is Kuldeep Yadav. So these 3 players, I think we have missed it during the extraction, the data extraction. These players are not capped. I mean, they have not played IPL. I may be wrong, but I'm not pretty sure about these values. And since there are only very limited information about their matches and the statistics, we are going to negate these values for now in our analysis. For the next part, we analyze the wickets that these people have taken. Then again, we have different values. This gentleman, Kagiso Rabada, has been showing consistently. So we'll keep Kagiso in our top bowlers list for now, the number 1. And then we have players like Jasprit and Yuzvendra Chahal, which have been showing in economy. They've been showing in the number of wickets that they have taken. Then again, if we take a look at the matches, Yuzvendra Chahal and Jasprit Bumrah again, they top the chart. So we'll keep our bowlers, or the analysis, the initial analysis tells us that these 4 bowlers are going to be in our best 11, which is Kagiso Rabada, there is Jasprit Bumrah, Yuzvendra Chahal, and Nathan Coulter-Nile. So all these gentlemen will be in our best 11 for now. We will take a look at the visual representations of these parameters, and we'll get a best idea about how these people are performing accordingly. Now we'll take a look at the all-rounders again. So all these all-rounders, we have narrowed down our search or narrowed down the top all-rounders according to the strike rate. Because any all-rounder is, let's say for example, plays in the middle order, and there we actually need, or they are going to play in the death overs. Like that's the best probability we have with the all-rounders. So we have kept the strike rate as a parameter over there. So we'll have all the bowling all-rounders and the batting all-rounders, which we can help in our top all-rounders list. So according to that, we have kept the multiple parameters here, which are basically the batting parameters and the bowling parameters. So we have average, strike rate, runs, matches, and then we have bowling average, bowling strike rate, wickets, economy, and matches again. Okay, so we have done the matches twice, which we can only use once because this is exactly the same value, which we can ignore one of this. And then again, we have done only the ascending for a few of them. Bowling average and bowling strike rate and the economy is in ascending order. The other all parameters are in descending order. So this is the final data set that looks like according to the averages. So we have this gentleman Kieran Pollard, and this is also one of the redundancies from the data set, which we have not which we have got wrong during the extraction. This gentleman here, I think, haven't played a lot of matches in the IPL, and we have missed that in during the extraction. And then we have players like Krishna Gautam, then there is Jofra Archer, Mohammad Nabi, Andre Russell, Hardik Pandya. All these all-rounders are in our top list according to the averages. Now this is how we segregated them into the top all-rounders list, which is according to the strike rate. And this is how it looks like. The most is 178.57 and the least is 140.44. Since we have already taken the values above 140. Here averages also I'll tell you once. I think the average is starting from 29.98. This gentleman has a very good average, and then it goes down to 13.3, or we'll take 14.3 as the least amount of average. After this we have parameters like all the runs they have made. So this gentleman again tops the chart with 3,268 runs, and in the least we have Mohammad Nabi, which has 180 runs. And then we have Glenn Maxwell, Andre Russell, Hardik Pandya and Sunil Narayan, and all these people respectively. When we take a look at the matches over here, we have all these values for the number of matches they have played, where again Kieran Pollard actually tops the chart. And then we take a look at the bowling average, where the statistics have changed a little. So now Kieran Pollard is at the place third from the last, and the most number of bowling average, or the most average from a bowler, has been from Jofra Archer, who has played 35 matches, and the bowling average is somewhere around 21.33, and it goes down from here. The last is Krishna Gautam, who has 43.23. Now we have the bowling strike rate again. Here also the statistics have changed a little. So the strike rate goes, the least is for Andre Russell, and then we have the most bowling strike rate is for Krishna Gautam. And now we have the all-rounders wickets. So the most wicket goes to Sunil Narayan, who has somewhere around 143 wickets. The least is for Mohammad Nabi, who has 13 wickets. Now looking at all these information from these data, just by visually checking, or just by doing the initial analysis, you can figure out a few players who are going to top these charts. What you can do is rank these players starting from the first chart itself from 0 to 8. So whoever is on the, let's say, first rank, that's kind of how you can narrow your initial analysis. So that player, how many ranks he's getting among all these 8 parameters, that's how you can decide. Whoever has the least can go down in the final list. So this is for the economy. Then again we have Sunil Narayan, and the least is for Hardik Pandya. So from the above analysis, we can rank down from the place from 1 to 10. Just I've told you how you can do that. And the top all-rounder options are Andre Russell, Sunil Narayan, Hardik Pandya and Jofra Archer. So these 4 players are going to be amongst the best 11 that we are going to decide after this. Now analyzing the keepers data is also the similar task that we have done, but we have narrowed our search based on the average that these people are scoring. So we have kept it for more than 25. And according to that, these are the players who are in the list. So the most goes to Johnny Bairstow, who has the average of 41.50, and the least goes to Dinesh Karthik, who has an average of 25.80. After this, we have the parameters like strike rate, then there is keeper runs, and we have matches, catches that they have taken, the runouts and the stumps. Now this one is an easier analysis for us, because in most of these parameters only one person is going to top the chart, but we have narrowed it down to 3 still. So for the keeper strike rate, then again we have Joss Butler, who is topping the chart with 150 strike rate, and the least goes to KS Bharat, who has 122.40. After this we have the top keeper runs, where MS Dhoni has 4,746 runs, which is the most. And then we have Dinesh Karthik and Ambati Rayudu. And at the least we have KS Bharat, who has only played 8 matches and has scored 191 runs. After this we have the top keepers matches, how many matches these guys have played. Then again we have KS Bharat at the bottom with just 8 matches, and MS Dhoni topping the chart with 220 matches played. And Dinesh Karthik has played 213, then 175. And then again we have the second last at Johnny Bairstow, who has 28 matches in his kitty, and he has already scored 1000 runs with the most average. Now again we have these people who have made the most catches and the most runouts and stumps as well. So without any doubt, we have MS Dhoni topping the chart in all these three. Then again, we have Dinesh Karthik at the second spot, and the third spot keeps changing according to the parameters. For runouts, it's Ambati Rayudu. For catches, it's Sanju Samson, and for stumps, it's Quinton de Kock. So these are the parameters and the players that we have initially analyzed through these findings, and we have narrowed our search down to three players, which is MS Dhoni, Dinesh Karthik, and Rishabh Pant. So according to the matches played, the runs scored, the average, strike rate, catches, runouts, and stumps, we have ranked them down from 1 to 10 according to where they are standing in the list, and according to that we have come up with the three players. So we have done the same thing for all these players. We have basically ranked them based on where they're standing in the list according to one parameter, and adding all those positions or the ranks, whoever has got the less or the least rank is topping the charts in our findings. So this is the basic initial analysis that you can do for any data, and you can find the relationship between how these elements will perform on different parameters. Not only, since this is a very simple data set, we have curated this according to our analysis, and it's very easy to just make out these findings. Otherwise, if you are using some complex data, for example, the analysis has to be somewhat extensive. It has to be a little bit more complex, where you will use more relationship wise on how each of these parameters are aligned towards each other. For example, let's say the number of matches somebody is playing is going to be linearly related to how many runs they're scoring. Because, for example, let's say somebody has played 500 matches, so they have got more number of chances to score runs, and let's say they have scored 5,000, 6,000 runs. So that's how the relationship will go inside the data. So matches played, runs, or let's say, for example, if somebody is making 126 catches, that is because they have played more number of games. Now if we average it down to how many catches per match, then that is another question which we can use in our extensive analysis, where we use more number of parameters. Like I've told you, for batsmen you can do the same, for keepers you can do the same, for bowlers you can do the same, for all-rounders as well. Like these parameters will keep on growing if you narrow down your analysis to a point where you want the exact results, or you want the exact information about any of these statistics. And now that we have done the initial analysis, let's move on to the visualization of each of these parameters, so that we get a clear understanding of these findings that we have done. For visual representation, we are going to do it on the segregated data we have done so far, and we are going to plot the exact same graphs we have done for our initial analysis. That's what we have done in our basic initial analysis, which is nothing but getting the information about averages and strike rates and all those things. So first of all, we are going to visualize the batters data. Now the plot shows here the top batters strike rate. So here, instead of looking at the data set with all these values of top strike rates, what we can do is just visualize them, and based on this we can just figure out which player has the highest strike rate. So David Warner, then we have KL Rahul somewhere along the same lines, and then we have David Miller also. So we can do the same thing for runs. So this is how it looks like. So the most runs is by Virat Kohli, and then we have David Warner, there is Shikhar Dhawan, KL Rahul is also among the top 4 here. Faf du Plessis is also just behind KL Rahul. So this is how easy it becomes to just visually analyze the data using Matplotlib, or we are using the bar plots here from Seaborn library, where you just give the x-axis, which we have used the player name from the data set, the top batters, and this is basically the runs we are getting. We just change the values over here in the y-axis. Now we are getting the averages from each of these players. Now if you take a look at this, the most number of the highest average is with these two people, KL Rahul and Ruturaj Gaikwad. Then somewhere down the lane we have Kane Williamson, who also has a good average. There is David Warner. So if I take a look at just Warner's finding in these three charts, or let's take a look at fourth one and we'll figure out. Fourth one is for the number of matches played. Here Virat Kohli is topping the chart. Then the second one is Shikhar Dhawan. Then there is David Warner, and KL Rahul and Faf du Plessis looks like just above each other. Maybe a few numbers are here and there. Somewhere around 100 matches both of these players have played. Now the question is, just by looking at David Warner's data, can we not just figure out he's actually in the top 5 of all these 4 and almost topping the chart in one of them? And then again, if we take a look at Virat Kohli, he's also somewhere around in all the 4 charts over here. And the third player that we have with KL Rahul, he's topping the chart here almost. Then we have him here also, where we have mentioned all the runs. Then we have him here at the average, which is the highest with any batter. And then in the matches also, he's not the one exactly in the top, but he's not at the end also. He's somewhere in the middle. So that's how we have narrowed down our search for the 3 batsmen like that. We have KL Rahul, Virat Kohli and David Warner. Now we visualize the bowlers data. Now again, for bowlers data, we have a few redundancies where we have null values which we replaced by 0. So that's why we are not getting enough values in these 3 columns. Otherwise, we have the values for other bowlers here. So first of all, we have the bowling average. So the lowest bowling average sits with these 3 people. And Alzar is Joseph. There is Kagiso Rabada, Lungi Angidi and Hendrik Nokia. And the highest is with Varun Chakravarti and Jasprit Bumrah. So from here we can figure out that these 2 people might be in our list. Now we go down the second parameter, which is the economy. So who has the lowest economy among this lot? So we have Varun Chakravarti, Nathan Coulter-Nile is also not doing so bad. Then we have Yuzvendra Chahal, Jasprit Bumrah and Hendrik Nokia. So these people are lowest in the economy section. Then we analyze the bowling strike rate. So the lowest sits with Lungi Angidi, Alzari Joseph, Kagiso Rabada, and then we have Hendrik Nokia. Arshdeep Singh also has a bowling strike rate which is considerably low compared to these people. And then we go to wickets. Here, Yuzvendra Chahal and Jasprit Bumrah are topping the charts by considerable numbers. For matches played, if we consider, the same thing happens. So from this lot, we have analyzed our 4 players according to these particular parameters that we have used for bowlers. Then for all-rounders, we are considering more number of parameters, which begins with strike rate. So we have Andre Russell topping the chart over here. Then for average, we have Kieran Pollard, who is having the most number of average. And then we have players like Hardik Pandya, who's I think at the top 3 over here. Here also he's somewhere around the top section, but let's say in the middle. Krishna Bhagautam here is actually having a good strike rate, but in the second one he's considerably low compared to the other people. So similarly, when we take a look at matches played, 2 people have considerably higher number of matches and the others are not there exactly. Then when we come down to runs, of course, since Kieran Pollard had more average, more number of matches played, he has also created a lot of runs. And that's the exact same thing with these people also, Glenn Maxwell, Hardik Pandya and other people who have played more number of matches compared to the others. And that's how these 2 parameters are actually related to each other, number of matches and runs. We have the bowling average where the lowest is with Sunil Narayan, Jofra Archer, and then the highest is with Krishna Bhagautam. And then again for the next parameter that we have, which is the economy, the lowest I think is with Sunil Narayan. Then we have Moeen Ali. Aman Khan we are not considering because this was kind of an outlier, we can say, or a noise in our data which we could not get rid of, because during extraction this was the anomaly we could not get rid of. And there is Jofra Archer, Mohammad Nabi, but Andre Russell and Hardik Pandya are actually not very efficient when it comes down to economy. But when we rank them down, let's say for example Hardik Pandya, if we consider in these charts, he's actually, let's say, amongst the top 5 players that we are getting. Only in the section where we have economy, the bowling strike rate and all these criteria, there I think he's lacking a little bit and coming in the middle. Otherwise, he's actually topping the charts in all these parameters. That's why we have kept him in our list of all these bowlers. Now if we take a look at the wickets also, Sunil Narayan compared to any other player has the most wickets over here. Then we have Andre Russell. Hardik Pandya also has a lot of wickets. Kieran Pollard is there, and Jofra Archer also is having a lot of wickets. And here also the economy, I think the bowling strike rate is very low for Jofra Archer. Economy is also among the middle over here. And then if you take a look at the bowling average, it's considerably the most efficient over here. And that's why we have kept Jofra Archer in our list also. After the wickets, we come down to analyzing the keepers data. Now here, let's say this is MS Dhoni in the olive color over here. He's going to top at least all the charts over here, that because he's considerably the most dominating keeper in this section, and that's why we have kept him in our best 11. The other players which we kept, like Rishabh Pant and Dinesh Karthik, if we see for the average, Rishabh Pant has a very significant amount of average over here. Although Dinesh Karthik is not topping the chart here, he is considerably ahead of all these people in runs. Rishabh Pant is also among the top 5 here, and MS Dhoni is again topping this chart. When we take a look at strike rate, Dinesh Karthik might not be in the top 5 over here, but Rishabh Pant is actually among the top 3, with MS Dhoni just below, or we can say just above Dinesh Karthik over here. The most sits with Josh Butler. And then again, if we take a look at the catches, Dinesh Karthik and MS Dhoni are topping the chart over here, with Rishabh Pant being in top 5 with compared to Sanju Samson and Ambati Rayudu, who are also doing considerably good over here. So visually representing the data helps you in analyzing it much more efficiently, because ranking down players like that can be a little bit trickier, and you can just look at the data from these charts and decide on your own. So over here, if we take a look at the runouts, most sits with the MS Dhoni, and then Rishabh Pant is among the top 5. Some of them have no values over here. Ambati Rayudu, Dinesh Karthik also I think is the second highest over here. That's why we have kept Dinesh Karthik in our top 3 list, because except 1 or 2 in all the parameters, considering stumps, runouts, catches, Dinesh Karthik is actually at number 2, and that's why we have kept him with Rishabh Pant in our top 3. For matches played also, Dinesh Karthik is at number 2, MS Dhoni at number 1, Ambati Rayudu at 3, Sanju Samson 4, and Rishabh Pant at 5. So considering all these visual representations, we have narrowed down our search, where we have finalized 3 batsmen, 4 bowlers, 4 all-rounders, and 3 wicket keepers. Now from these people, we will visualize some more information, and according to our problem statement, we'll come up with the final 11. So now to form our best 11, we have to focus on a few things. First of all, we have to consider the number of players from each category that the T20 World Cup winning team had in their squad. And I also told you we'll consider the IPL's winning team for the last campaign. So Australia won the T20 World Cup, and they had 3 batsmen, 3 all-rounders, 4 bowlers with 1 spin option and 1 wicket keeper in their squad in the final match. And for Chennai Super Kings, the squad had consisted of 4 batsmen, 3 all-rounders, 3 bowlers, and 1 wicket keeper. So taking into account these 2 statistics, we can narrow down our search for the best 11 according to 3 batsmen, 3 all-rounders. We keep 4 bowlers with 2 spin options, or we'll try to stick to 2 spin options, and we'll have 1 wicket keeper. So now after this is a very simple representation of all the batsmen with all their parameters that we have analyzed them on. So for example, we finalized David Warner, Virat Kohli, and KL Rahul for our batsman category. So we have stored their all the values in whatever information they had in their data frames, and visualized them on our graph over here. For each graph displays certain information, which is matches played, runs in the IPL, average, and strike rate. So for the top 3 over here, KL Rahul has the least number of matches, but he has the second highest strike rate and the highest average over here. Even though David Warner has the matches played in the range of let's say 150 matches only, The strike rate is the highest among the three, and the average is also in the middle. And when we consider Virat Kohli, for the number of matches he has played, he has been consistent with the average, and there is enough data on strike rate, which is more than 120, and 6,000 IP runs. So this is how we have just narrowed our analysis to just the parameters we want our three batsmen to look for. Similarly, we have done the same for the all-rounders. So we had finalized Andre Russell, Sunil Narayan, Hardik Pandya, and we left out Jofra Archer because we are only allowed to keep 4 overseas players in the best 11. That's why we have kept Andre Russell, Sunil Narayan, and Hardik Pandya only. Now we have gathered all their values for specific parameters from the dataset top all-rounders. I forgot to mention this for batsman data. So we are just locating these rows where these people or these batsmen have been placed in the dataset and extracting that information so that we can display it on the graphs. And we are using the subplots to plot these graphs in the same space, and we're using the bar plot from the Seaborn library. If you have any questions, you can mention them in the comment section below, guys, because this might be a little bit complicated for a few beginners, how we have used these axes and all. We have just declared this subplot 2 by 2, where this is 0 by 0, this is going to be 0 by 1, this is going to be 1 by 0 and 1 by 1. So this is how we are subplotting these 4 plots in just one big image. And we have done the same for this also, where we have used 4 by 2 subplots, where we have 2 subplots each side, and this is one big image where we are getting all these information. So we have done this for bowling average, wickets values, and economy values, and all these parameters we used the all-rounders to analyze. So for these 3 players, we have matches, the runs they have scored, considerably how many number of matches Sunil Narayan has played. The runs are a little bit on the lower side, but the number of wickets are on the top here, and that basically shows that Sunil Narayan is kind of a bowling all-rounder and a spin option again. That's just additional information I'm giving out here. That's not mentioned in the dataset anywhere, guys. Also, if we take a look at Hardik Pandya, we have the number of matches played more than, I think, 80 mark over here, somewhere around 100 or less than 100, and the runs he has made is almost as good as 1400. The strike rate, the average, the bowling average is on the higher side. So this basically shows that he is kind of a batting all-rounder, but he has been taking wickets, which is kind of around 40 wickets he has taken. The economy is also on the higher side here. Andre Russell is a complete package in that sense, because the number of matches played, the runs, the wickets he has taken, economy is a little bit on the higher side, but the bowling average also is a little bit lower, because we have narrowed it down to just 3 people. That's how we are getting these values for just the 3 of these all-rounders. Similarly, we have done the same thing for the bowlers. So the bowlers are only analyzed on 3-4 parameters, which is the number of matches they have played, bowling average, strike rate, wickets, and economy. And this chart basically has been left empty because we had initialized the 3 by 2 plot over here, and we didn't initialize anything for here. Alright, so this is how we can just represent our analysis, or these are the findings we got from our analysis. We are putting it down to our visual representation so that we get a more clear idea on how these players are looking like according to these parameters. Similarly, if we do it for example, let's say, so we had 3 players in the data over here for wicket keepers, but we have narrowed it down to just 1, because only 1 player will play as a wicket keeper in the entire team. So we have narrowed it down to just the top player, which is MS Dhoni. And if we take a look at the matches and the runs, so this guy has played somewhere around 220 matches, and the runs are more than 4,000, closer to 5,000 mark over here. If we take a look at the average and the strike rate, average stands somewhere around 40, and the strike rate is more than 130. Then again, the keeping stats, number of catches is 120 plus. If we take a look at we can compare these values to matches according to our analysis. We can add hue over here, add number of matches, and compare the values of catches, stumps, and runouts to get a better picture of the analysis. This is how you can extend your analysis based on more parameters. You can figure out how many catches per match or statistics like that. Now, after we are done representing all these values or all these statistics about our final 11, we consolidate that information in a single data set, and that's how we have done it over here. We have used the concatenation function from pandas to concatenate all these different data frames. We have consolidated using the LOC method for pandas, and we have consolidated final team and dropped all these different values or parameters like matches played, which we have analyzed them upon. Now we just need the team that they are playing for and the nationality, because we have to decide how many overseas players can play in that team. So coming back to our presentation, guys, so results from our analysis shows that these are the final 11 according to the parameters that we used in our analysis. That stands a good chance. So this is the best 11, which consists of KL Rahul, David Warner, Virat Kohli as batsman, Andre Russell, Sunil Narayan, Hardik Pandya as all-rounders, MS Dhoni as keeper, Nathan Coulter-Nile, Kagiso Rabada, Jasprit Bumrah, and Yuzvendra Chahal as bowlers. And we still have two bowling options that are going to offer spin, which is Sunil Narayan and Yuzvendra Chahal. And this is where we come to the end of the session, guys. So to think of this as an extensive analysis is not a very good idea, because we had only used very specific parameters, and if you analyze any cricketing data, you have to extend your research to more number of parameters to make it more foolproof. The idea behind this session was to show you how you can analyze any type of data. It could be any data related to anything. And now that we have come to the end of the session, if you have any questions, you can mention them in the comment section below, and we'll be happy to help you in your journey towards data analysis or data science. Thank you and have a nice day. Now that we are done with the session, don't forget to subscribe and press the bell icon to get the latest updates on Intellipaat.